All right, here's a video on Module 2, Homework 1. All right, so we're going to go ahead and go through that. And when we're graphing coordinate points, we graph coordinate points based off of ordered pairs. So we always look at graphing ordered pairs by X and Y. So that's how we graph. All right. So when we're looking at, like, for example, A in here, A is at the origin and it's in the center. And the center is always 0, 0. All right, that's coordinate point because you're moving nowhere left or right. So that answer is going to be, it's actually at the origin, yeah. So we say it's at the origin, okay, because it's pointing out where we are. But that's 0, 0, okay. We need to point out the origin and where we are, okay. Now, when we are looking at B, B is located here. That is, we always look at these as this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. That's how we look at these, okay? So when we're looking at what quadrant, this is going to be in the fourth quadrant, and the coordinate point is going to be at 1, -3. All right? And then for C, C is located on the y-axis. It's going to be, when we're looking at the y-axis, it's always going to be x equals 0. So it's going to be 0, -1, and it's on the y-axis. For D, D is on the x-axis, so it's going to be 3, 0. For E, E is in the first quadrant, and it's at the coordinate point of, and we always label the x first, so it's always 2 and then 4. So 2, 4. For F, F is located at the second quadrant, and we're looking at -1, 2. G is at -2, -3, and that is the third quadrant. All right, so we're looking at the different quadrants and what the coordinate points are for them. Now, plotting the point 2, 5, we would go 1, 2, and then up 5, and we got the coordinate point graphed, and we're done with that one. All right, so graphing 1, -4, it's going to be 1, -4, it's going to be right here. Whoops, I accidentally hit submit answer. Like I really care about submitting my answer. I know I got it right. Okay. Now, finding the coordinate of the point plotted, we're going to go ahead and label the x first, -4, 3. So always label the x and then the y. So always over and then up. Plotting the points 0, 1, we're going to go 0, 1, so that's right here. And then 2 over, down 2, and then 4, 0. So 4 and then 0. Okay. This one is 0, 1. That should be up here. I would have to take this one out. I have to erase this one. How do I erase it? I can't. I would have to clear them all. I'm not going to bother. So I accidentally, that one's 0, 1 is right here. I accidentally put it in the wrong section. Sorry about that, guys. Even I goofed it up. So anyway, it's not, that's 0, 1. Okay, let's go ahead and see that right here. Okay, this is pretty straightforward. So when we're looking at the graphs, -1, 3 is right here, 5, 1 is right there, -3, -5 is down here, 4, 0 is right there, 4, -4 is down here, and then 0, 1 is right there. And it looks like we match. All right, these move very fast. Now this is producing input and output, as well as then putting output and seeing what input would be. So then it's 5 for the value of x. So then the y would be -4, because you would subtract 5 from both sides. 4, if you guys need me to physically write that down, it'd be 4 plus y equals 1. You would subtract 4 from both sides and get 1 minus 4. Now, I do it mentally for you guys because it's pretty fast if you can do it mentally. You don't need to write everything down. Your teachers in high school probably made you do that, and that was just annoying to you probably, but you can do things mentally, and it's acceptable. Here you go ahead, and some of you are like, oh, Dr. D, you're going too fast. Well, it's because you probably need to work on your simple addition and subtraction in your head, because all I'm doing is simply subtracting 2 from both sides and getting -1. That shouldn't be overcomplicated. And I could have done that mentally, okay? And then you graph those coordinate points as we did before, and you would get the following coordinates graph. Now, they want you to actually graph the equation like we did in the other lessons, but this one right here, we would go ahead and graph that simply by graphing those coordinate points. You can take this and graph that coordinate point 5. Like if you go to 5, that's +5 for x, +5, and then -4. You go ahead and do this. And then you can go ahead and graph the other one. It'd be +4, -3 is right here. You go ahead and graph this one, -1, 2, it'd be right here. This is the other point of interest. But that's exactly what we have already here. Okay. Now tell whether the equation is linear or not. How you can tell if it's linear is that both the x and the y coordinates would have 1 for the value of their degree power. This one is linear. This one's, yes, this is linear. All right. This one's not, because the y, okay, is degree power 3. So that's not linear. And you can't have fractions either. Fractions means that if we brought up the x value, it'd be -1 for the value of the exponential power. Same thing goes for the y. You would have -1 for that as well. And so this one will not be linear. So that's pretty simple. If you have the y and x equaling 1 for the value of the exponential power. So for the equation such, complete the table, all this is making you do is put in -2 in for x. So -2 plus 4 is 2. 0 plus 4 is 4. 2 plus 4 is 6. I mean, this is coming down to elementary. All right, very elementary. Okay. So we have that. And then, of course, they want you to graph it. All right. So then graphing it, we would go ahead and put a dot here. All right. And then up 1 over 1 and put a dot there. And then we go ahead and get our answer. All right. So simple as that, because we know how to graph based off of coordinate points. But we could go ahead and see that 0, 4 and then go to 2. And then we could see that 2, 6 is another coordinate point of interest. Okay. Now we have this one right here. The way to write this, okay. Another way of writing this, students get confused when it comes down to fractions being written like this. When you have this as x over 3, another way of writing it is 1/3 of x minus 1. All right. In other words, we drop the x away from the numerator and just put it on its side. And when we remultiply this out, it would be x over 3. But we like it this way because this is mx plus b. All right. So that would give us then our graph, but it's asking us to still put in values for the x. All right. So we're going to go ahead and put -3 in for x, and then we have -3 divided by 3 is -1. -1 minus 1 is -2. So that would be our coordinate point value for that. So that would be our answer for this one is -2. And if you do 0 times anything, that means it's going away, and it's going to be -1 for that answer. And then if you go ahead and put in +3, it'd be 3 divided by 3 is +1. +1 minus 1 is 0. So you would go ahead and get 0 here. So we would go ahead and graph the coordinate point of this at 0, -1 would be right here. Whoops, that's not it. I gotta wait for a little bit. It's still loading. It's got an issue. There we go. It's coming back. Okay. Now I'm going to go ahead and see that I go to 3, 3, 0. It's right here. All right. And then that would be my answer that I'm looking for graphing. See, all you need is for a linear equation is 2 points to make a line. So we're done with that. So now for question number 11, it says fill in the table T. We're doing the same idea, is taking -1 times 3 is -3 plus 5 is -8. And then 0 times 3 is 0 plus -5 is -5. You notice how I said plus -5? Because I always think about it as the addition of integers. That's how I always think about it. So it's 1 times 3 is 3. 3 minus 5, if you wish, is -2. So we have our coordinate points now. We can go ahead and graph that. So we go down to 0, -5 is right here. And then we go ahead and go 1, -2 is right here. All right. So 1, -2 is right there. And we would get our graph. All right. So I'm going to go ahead and see that that's the same thing we have. All right. So it's a matter of graphing it. So now when you have several ordered pairs, now this is not linear. This is going to be a curve. This is going to what we call the quadratic equation. Quadratic is going to have a U-shaped like looking figure. It can go like this, or it can go like this. It has a U-shaped like looking figure. Okay. Now, whenever it's x squared minus 5, it's going to be the U-shaped like looking figure that was at the origin. This is what typically it looks like. All right, this is what it typically looks like. Now, because of -5, it's going to drop 5 units. 1, 2, 3, 4, 5. So now it's going to look like this. And it's going to have symmetrical properties. So if it's this many units away from the origin, it's going to be that many units away from the origin on the other side. Okay, it's going to have very symmetrical properties to it. So just by looking at this right here, I can see the answer is already this one. All right, but that still doesn't hold us not responsible for filling in the pieces. So if I put in -3 in here, for example, I put in -3. If -3 is going to be squared, by the way, -3 squared is 9. 9 minus 5 is going to give us 4. So I get -3, 4. And that's where the coordinate point rests right here. All right. Now, if I put in -2, -2 squared is going to be 4. And 4 minus 5 is -1. So that's my coordinate point for that. If I put in 1, -1 that is, -1 squared is 1. And then -5 is going to give us -4. So I'm looking for that as an answer there. And if I put in 0, 0 squared minus 5 is going to give us -5. And then that's the answer we look for that. But now watch what happens. If I go ahead and put 1 in there and square it, it's still going to give you 1 minus 5 is -4. So it's like a boomerang effect. It's going out as far as it can, and it's coming back exactly the same path, except for on its, the other branch, I call it. But then if you put in exactly like, if you put in 2 again, 2 squared is 4, 4 minus 5 is going to be still -1. And likewise, 3 squared is still 9, 9 minus 5 is still going to be 4. So it's going to have this boomerang effect. You throw out a boomerang and it's going to come right back and create the other branch. All right, and that's why these are mimicking or look the same. All right, so that's the quadratic. It looks like a U-shaped like looking figure. Now this is a linear equation, so it's going to be a straight line. So again, you put a -1 times 3 That's negative 3. Negative 3 plus 6 is negative, or excuse me, positive 3. Put in 0. 0 plus 6 is 6. Put in 1. 1 times 3 is 3. And then 3 plus 6 is 9. So it has a linear effect. It doesn't have a rebound effect like the other one, like this one. All right, where it comes back. So you graph two of those points like I have in the past, and you can get the answer of what we're looking for here, graphing any of those 2 points. You can go ahead and get 0, 6 right here and graph 1, 9, which is right there, and you can get the 2 points that you need just by going ahead and doing that. All right, here's an example. Just click this and go up 3, 1, 2, 3 over 1, and then you get your answer. Okay. And then likewise, you're doing the same thing for this. You're putting in the x, so negative 3 times 2 is negative 6 minus 3y equals negative 12. You go ahead and add 6 to both sides, and you get negative 6, and then you get y equals 2. So that's a little bit more work when it gives it to you like that. It's kind of like, ouch. It's a little annoying. All right. So that's the answer we're looking for there. All right. Oh, I was off the page. I apologize. All right. There we have the work. I've written it, but I was off the frame. All right. Now, if you put in 0, 0 times x is going to be, x is going to be 0. So then we're looking at 0 minus 3y equals negative 12. And so therefore, it's going to equal y equals 4. And so we have our answer for that one. And then 3 times 6 is going to be, or 3 times 2, excuse me, is positive 6. Negative 3 equals negative 12. And this time I would subtract 6 from both sides and get negative 18. And then divide both sides by negative 3. And we get 6. All right, so we have that right there. So 2, 4, 6. So graphing that, we would go 0, 4 right here, and then go to 3, 1, 2, 3, and then go up 6 right here. All right, and there we have our graph. So we have our answer for that one, 15. Now absolute value, a little bit about absolute value. Absolute value looks like a V-like looking shape figure. So the absolute value looks like this. So it's what we actually call a piecewise function. So this one, because it's negative 5 in front of it, what happens when you do that, it flips upside down and makes it really super narrow. So it looks like this when it's negative 5 placed in front of it, because it increases the speed at which it's going down. So we're looking at something that looks like that. So now, by clarification, this looks very hard to see the difference between these two value systems. So it would be one of these two. So I would go ahead and have to put the answers or the numbers in there. Now, what does absolute value mean is it's the distance away from 0 that any number is. So negative 3, when we put a negative 3 in, it's still only 3 units away from 0. So it becomes positive. Now, I don't like it when students say, well, anything that's an absolute value is positive. That doesn't clarify what the definition means. It's when we put in negative 3, it's 3 units away from 0. So 3 times negative 5 is negative 15. Then when we go ahead and put in negative 2 is 2 units away from 0. So it's going to be 2 times negative 5 is negative 10. So you get these coordinate points. All right. So then this is what we're looking for is the negative 15, the negative 10, and then you get a negative 5 because negative 5 times positive 1, and then 0 times anything is 0. And then 1 times negative 5 is negative 5. 2 times negative 5 is negative 10. And so that's that same kind of property as the quadratic, is that has kind of similarity properties. It has symmetrical properties to it. So when we get that kind of value system, we have to kind of zoom in on this to make sure that that's the output value systems that we're looking for. We should have -1, 5, and it's -1, -5 is that one, and that one's good. -2 is 10, that's good. -3 was 15, that's good. This one's the answer we're looking for. So this is the answer. All right. This one, it looks very, very similar to it, but if you look at it closely, then it's -1, -3. That does not work. It's not giving us the 5 that we're looking for. -2, -6, that's not working. It looks like it's multiplying by 3. So it has a multiplier by 3, -3, not -5. So that's why the difference between them. Okay. So that's why the answer is that one. So this one says, for the given graph, what is the value of y when x equals -2? So you look for -2, and the y value, you look for -2 is right here. The y value is -1, which is right there. So because you can see where this line crosses over that point, and then that's what we're interested in. So the answer is -1. And then right here, determine whether each of the ordered pair is a solution. So you're going to put them into the equation, all right, and determine if it works. So I go ahead and do 2 times -1, and then plus 2 times 1.5, and then equals 1, and see if that works. Well, this is going to give us -2. This is going to give us +3, because it's 1, and then half of 2 is 1, and 1 plus 2 is 3. So, I mean, you could take a calculator if you don't trust me, all right? And you can get the answer. And this one does work because -2 plus 3 does work, all right? So the answer is yes, that works. And likewise, we do the same thing. We do 2 times 1 plus 2 times 0.5, and ask ourselves, does that equal 1? Well, this is 2 plus 1, and that does not equal 1. So that's a false statement. So that's no. So we put in 3, 2 times 3, and then we do -2.5, right, times 2, and then that we get that. So this is going to be 6 minus 5 equals 1. And again, you can use a calculator, and then this would be equal to each other. So this checks off. So therefore, this one's yes. Sometimes some of you need calculators. You don't know, like doubling 2.5 gives you 5. I don't know how to help you there, except for you need to use a calculator. All right. So now number 18, the last one, we're looking at y equals, and then it's -1 times -9 minus 4. And then this is going to give us, we're looking for what the output's going to be. Then that's going to be -9 times, -1 is +9, excuse me. And then we have -4, and that's going to give us equal to 5. All right, so that's the answer we're looking for that. All right, and then we go ahead and put the output value at -14 and ask ourselves, what does that mean for the x value now? So we will go ahead and add 4 to both sides, get -10 equals -x. And then you can't have a negative value x in there, so you just switch the signs, and then therefore it's going to be x equals +10. So that's what we're looking for there. And then last couple here, we would go ahead and put in -6 for the value of x. So we get -6 times -1 is +6 minus 4, and then y equals 2. So you get the value of that. And then lastly, we have the y output is 3. So we put in 3 for the y output equals -x minus 4. We'd add 4 to both sides, get 7 equals -x, and then x equals -7. So there's our answer for that. All right. So that is lesson module 1 homework, module 2 homework 1. All right. Actually, need to be clear about that. All right, and that concludes that homework.